Lightning is an electrical discharge between clouds and ground. A storm cloud has negative charges at the bottom layer, and all objects on the ground have positive charges collected under the cloud. During the storm, all negative charges start moving downwards in the form of branches and stop at around 200 meters above the ground. At that moment, all positive charges of the objects on the ground are emitted towards negatively charged branches in the sky. One of the positive charges meet with one of the negative ones, and this forms a conductive channel which is called lightning. All of the current inside cloud flows to the ground through this channel and through the object which emitted the positive charged branch. Lightning is mostly observed in equatorial regions. Countries in this region experience extremely damaging results of lightning strikes, which creates more than 50% of overall damage by natural disasters. With the industrial point of view, telecommunication and radio towers are the primary targets of lightning. However, wind turbines, power transmission towers, and tower cranes are also under a serious risk of lightning damage. Lightning is the biggest threat for metal structures such as telecommunication and radio TV towers. Studies show that the rate of service lost by lightning-related damage is 40 to 60% of all downtime for mobile operators, and the cost of lightning damage to telecom industry is millions of dollars every year. A telecom tower is the primary target for lightning strikes. When lightning hits the tower, the current flows through the tower legs and gives damage to any equipment on tower and inside shelter nearby. This takes the site out of service and all equipment need to be replaced. Lightning is a beauty of nature, but there is definitely a need for protection against lightning-related damages. There are basically two ways of lightning protection. First method is attracting lightning, and the second is preventing the strikes. Lightning arresters have two different types of products which are called lightning rods and ESC systems. Both product types do the same job and try to attract lightning on the desired point in order to protect the environment. The system has a primary unit, the lightning arrestor, and it is connected to a conductor, which is also connected to a conductive grounding unit. The goal is to attract the lightning on the arrestor and transfer the current to conductor cable and finally to grounding system. This solution works for ordinary buildings made with concrete materials, since that conductor cable is a better path for the lightning current. However, when it's applied on a metal tower, it collects the lightning on itself, but the current flows down to the ground through the tower body, which again damages all equipment on tower and inside shelter. This results with the loss of equipment, long-time service cuts, and the big cost of money to infrastructure companies and the mobile operators. According to fundamental physics principles, all objects emit charges, but sharper and smaller objects do faster and more emission comparing to larger flat surfaces. Comparing to traditional lightning rods, a rod with multiple sharp tiny pins emits and dissipates the charges much faster until there is no charge left in the environment. This is the basic principle of EvoDis lightning prevention system. EvoDis system dissipates the charges on metal towers and make the towers invisible to lightning. This process mitigates the risk of getting hit by lightning strikes and protects the equipment on tower and inside shelter. EvoDis has been applied over hundreds of towers worldwide, which had so many lightning-related damages until the date of installations. EvoDis protects all of them with zero failure for over 10 years. EvoDis lightning prevention system protects your business and supports your operation.